All right. Hello again, IB. This is Miss Kosh. I should go grade your tests or quizzes or whatever I'm supposed to grade, but I feel like doing another induction proof. So here we go. This first one, I'm going to always begin. This is the second video, so go watch the first one if you haven't already. Step one is always to say that n is equal to 1. So now we're going to say the sum as I goes from 1 to 1. We could say this is the left-hand side of I squared, that's equal to 1, well, squared, which is still just equal to 1. Okay, and then on the right-hand side, we have 1 times 1 plus 1 times 2 times 1 plus 1. Oh my goodness. Okay, over 6. Well, that's equal to 1 times 2 times 3 over 6. Well, 6 divided by 6 is equal to 1. And now we've shown that our left-hand side and our right-hand side match. Okay, step 2 says, assume, there's how you spell, I can't spell, n equals k is true. Okay, so what we'll do is we'll say, all right, the sum as I goes from 1 to k of I squared is equal to k times k plus 1. By the way, k is your favorite letter because it's my favorite letter, so it gets to be your favorite letter, all over 6. Okay, that was step 2. Step 3 now tells us we're going to prove or show, or I don't know what I wrote, n equals k plus 1. It doesn't matter a whole lot. That's step 3. Now before, well, okay, so that means the sum as I goes from 1 to k plus 1 of I squared is going to be equal to, well, okay, it's the sum of the first k terms plus that k plus 1th term. Well, so what do I get? How do I get the k plus 1th term? I come back here and plug in k plus 1. When I do, sorry, I'm about to cough, I have k plus 1 squared. Okay, now at this point, this might be a good point to kind of stop and say, well, what was my goal? My goal is to get to k plus 1 times k plus 1 plus 1 times 2 times k plus 1, oh my goodness, plus 1, all over 6. What in the world is happening here? Notice what I did is I came to that equation, and anywhere I saw an n, I put in a k plus 1. And so this becomes k plus 1 times k plus 2 times, well, this is 2k plus 2, so 2k plus 2 plus 1 plus 2k plus 3, all over 6. That's our goal. That's what we're trying to find in our problem here. Okay, so coming back to the actual proof, that's scratch work. That can be really, really helpful, especially as these get really, really gross. But that's not part of your proof. All right, so what do we know? We know that this is this because we assumed it right before. Okay, so we can come along and say, well, this is equal to k times k plus 1 times 2k plus 1 over 6 plus, well, now we have a k plus 1 squared. What I would probably, I haven't thought about this problem in a year, so you're experiencing me thinking through this. What I would probably do is try and add it together, so I need to get a common denominator. So I'm going to multiply this by 6 over 6. And so now I have k times k plus 1 times 2k plus 1 plus 6 times k plus 1, parentheses, squared, over 6. What I notice is that each of those terms have a k plus 1. So when I factor that out, I get a k plus 1 has been factored out. What's left behind is a k times 2k plus 1 that came from this term. And then I have plus a 6 times a k plus 1 that came from that term. Okay, so everybody is still being divided by 6. And you can't lose that 6 just because you feel like it. Each statement, this is a proof, so each statement has to be true the whole way down to what came before the whole time. So yeah, sometimes that gets annoying that you have to hang on to it, but you got to do it anyway. All sorts of parts of life can be annoying. Okay, so here's, sorry. This becomes, what is this, 2k squared plus k plus 6k plus 6, all over 6. Okay, here's what I notice. It could be, when I'm at this point, I remember back to my goal. Like, it does help to have this goal. And so in my goal back here, I had a k plus 1, and I have a k plus 1 here. And so if this rest of this mess could factor down to that, life would be grand. So let's see if that's true. We need a k plus 2 times a 2k plus 3. Oh, we might be there. Let's see. Okay, hang on. Maybe I'll write this out. All over 6, does that factor? We have a k plus 1. What happens when I factor a k plus 2 times a, well, to get 2k squared, I have 2k times k. To get 6, I'm going to have a plus 3. Let's double check to make sure. I'm going to do, yeah, we'll use this times this is 3k, this times this is 4k, 3k plus 4k is 7k, that is good. And everything else is lovely. Okay, so now I've cluttered my paper with pink. Go up, well, whatever, plus 3. Okay, so I'm here and I'm almost there, you guys. So this becomes k plus 1 times k plus 1 plus 1 times, well, this is 2 times k plus 1 plus 1. And it seems kind of an arbitrary, everything's divided by 6. It seems arbitrary that we're going from here to here, but that's because we knew to do that back in our goal. Okay, so we were here and we were like, well, we got to go back to this. Well, we had already, that's how we had gotten there. Okay, so hopefully that makes some sense. And now we can say we've shown it. We have gone through, and our original equation, everywhere we had an n before, I'm trying to get it all on the screen. Everywhere we had an n before, we now have a k plus 1. So life is great. So we can therefore say, therefore is those 3 little dots, therefore the sum as I goes from 1 to n of I squared is equal to n times n plus 1 times 2n plus 1 all divided by 6. And there we go. I think they're fun, but they definitely take practice. So good luck. Let me know if you have questions.